welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 11. That what we'll have to discuss here, which is your class 16, and that we had done your class 15 where we had completed your unit 8, which is your redox reaction part 1, which we had completed in the last classes only. In terms of unit 9, which is of hydrogen, we had started with, and that of course we had done there some of the questions related to it which has been left, and this is your unit 10, which we'll start discussing, which is the S block elements. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So for this, before starting with this, as I told you, we'll discuss some of the questions related to it, unit 9, which is hydrogen. So here we go for it. 15 question we had done. Now next question is to arrange the following as CaH2, BeH2 and TiH2 in order of increasing electrical conductors. The next is LiH, NaH and SeSH in order to increasing ionic character. Another is hydrogen bond, D and D bond, F and F bond in order of increasing bond dissociation enthalpy. Another is NaH, Mg, H2 and H2O in order of increasing reducing properties. So another question is to compare the structures of H2 and H2O2. What do you understand by the term autoprotolysis of water? What is its significance? Another question is to consider the reactions of water and F2 and suggest in terms of oxidations and reduction which species are oxidized and reduced. Another question is to complete the following chemical reaction, which is PBS in solid plus H2O2 in aqueous will give. Another is MnO4 minus aqueous plus H2O2 aqueous. Another is CaO solid plus H2O gaseous. Another is AlCl3 gases plus H2O liquid. Another is Ca3N2 a solid plus H2O liquid. Here we'll be going for it. So another we discussed classify the above into hydrolysis, redox and hydration reaction. The another will discuss about to describe the structures of the common form of ice. What causes the temporary and the permanent hardness of water? Discuss the principles and methods of softening and hard water by synthetic ion exchange resistance. A white chemical reaction to show the amphoteric nature of water. Another is to write chemical reaction to justify that hydrogen peroxide can function as an oxidizing as well as reducing agent. The another we talk about it, which is what is meant by demineralized water and how can it be obtained. Another question is demineralized or distilled water useful for drinking purposes? If not, how can it be made useful? Another is to describe the usefulness of water in biosphere and biological system. Another is to what properties of water make it useful as a solvent, what types of compound can it dissolve and hydrolysis. Knowing the properties of H2O and D2O, do you think that D2O can be useful for drinking purposes? What is the difference between the term hydrolysis and hydration? How can saline hydrides remove traces of water from organic compound? What do you expect the nature of hydride is if formed by elements of atomic number 15, 19, 23 and 44 with dihydrogen? You have to compare their behavior towards the water. Do you expect different products in solutions when aluminium third chloride and potassium chloride treated separately with normal water and acidified water and alkaline water? Write equation wherever necessary. Another question is, how does H2O2 behave as a bleaching agent? The another is, what do you understand by the term hydrogen economy, hydrogenation, syngas, and water gas shift reaction, fuel cell. So here we're gonna end up with unit 9. Now we'll discuss the unit 10, which is your that is the S block element here. So for that we'll be going to start discussing about for the S block element. Before that, you have to know that the first element of alkali and alkaline earth metal differs in many respects from the other member of the group. So the S block element of the periodic table are those in which the last electron enters the outermost s orbital. As the s orbital can accommodate only two electrons, two groups, which is 1 and 2, belong to the S block to the periodic table and group 1 of the periodic table consists of the element that is your lithium, sodium, potassium, rubidium, cesium and francium. They are collectively known as alkali metal. They are so called because they form hydroxides on reactions with water, which are strongly alkaline in nature. The element of group 2 includes beryllium, magnesium, calcium, strontium, barium and radium. These elements, with exceptions of beryllium, are commonly known as an alkaline earth metal. These are so called because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in the earth crust. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium, and cesium have much lower abundance. Francium is highly radioactive and it is the longest lived isotopes, where it has a half-life cycle only 21 minutes. Of the alkaline earth metal, calcium and magnesium rank 5th and 6th in abundance respectively in the earth crust, and strontium and barium have much lower abundance, where beryllium is a rare and radium is the rarest of all, the comprising only 10 to the power 10% of igneous rock. Now, the general electronic configuration of S block elements in noble gases, that is NS1 for alkali metal and noble gas NS2 for alkaline earth metal. So here we go. So for the same, it will be the lithium and beryllium, the first element of group 1 and group 2 respectively, exhibit some properties which are different from those of other member of the respective group. In these anomalous properties, they resembles the second element of the following group. Thus, lithium shows similarities to magnesium and beryllium to aluminum in many of their properties, where this type of a diagonal similarity is commonly referred to as a diagonal relationship in the periodic table here. The diagonal relationship is due to the similarity in ionic sizes and charge radius ratio of the element here. Monovalent sodium and potassium ion and divalent magnesium and calcium ions are found in large proportion in biological fluid. These ions perform important biological function such as maintenance of ion balance and nerve impulse conduction. Now we talk about for the group 1 element, which is alkali metal. Group 1 element, which is alkali metal. So group 1 elements, that is your alkali metals. Here the alkali metal shows a regular trends in their physical and chemical properties with increasing atomic number. The atomic, physical and chemical properties of alkali metal are discussed here. So first we'll discuss about the electronic configuration. Electronic configuration. So for electronic configuration, so the electronic configuration being as follows: element, symbol and electronic configuration. Element, symbol, electronic configuration. So for that, here the first element we have for lithium. The symbol is Li. Electronic configuration is 1s2, 2s1. Another is sodium. The symbol is Na. And here element electronic configuration is 1s2, 2s2, 2p6, 3s1. So for potassium, the symbol is K. This is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now for the rubidium, the symbol is Rb, and the 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 5s1. Yeah, 4p6. Another one is your cesium. Symbol is Cs, and equation and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1, 4s2, 4p6, 4d10, 5s2, 5p6, 6s1, or we can say that. So for the same we go for it, and that is all. We can write it down: XzCS1, 6s1. Okay, now we'll talk about the last one, which is a francium. The symbol is Fr. Rn 7s1, मतलब ये पूरा Rn का पूरा, and then we will be having a 7s1. Rn 7s1 is the electronic configuration of francium. Now we talk about for the atomic and ionic radii. So for atomic and ionic radii here, so atomic and ionic radii, the alkali metal atom that have the largest sizes in a particular period of the periodic table. With increase in atomic number, the atom becomes larger, and the monovalent ion, which is M plus, that are smaller than the parent atom. The atomic and the ionic radii of alkali metal increases on moving down the group, that is, they increases in size while going from lithium to cesium here. Okay, they are the size increases in the size when they are going from lithium to cesium. Now for that, ionization enthalpy. So for ionization enthalpy, the ionization enthalpy of the alkali metals are considerably low and decrease down the group from lithium to cesium. This is because the effect of increasing size outweigh the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charges. Now we go for another one, which is hydration enthalpy. Hydration enthalpy. In terms of hydration enthalpy, the hydration enthalpies of alkali metal ion decreases with increase in the ionic sizes, and that we have Li plus is greater Na plus, K plus, Rb plus, N plus, and Cs. So Li plus, that has a maximum degree of hydration, and for this reason the lithium salts are mostly hydrated, which is example is LiCl dot 2H2O. Now we talk about the physical properties. Physical properties. So in terms of physical properties, here that all the alkali metal are silvery white, soft and light metals, and because of the large size, these elements have low density, which increases down and the group from lithium to cesium. However, potassium is lighter than sodium, and the melting and boiling point of the alkali metals are low, indicating weak metallic bonding due to the presence of only a single valence electron in them, and the alkali metal and their salts impart characteristics color to an oxidizing flame. This is because the heat from the flame excites the outermost orbital electron to the higher energy level, and when the excited electron comes back to the ground state, there is the emissions of radiation in the visible region as that to be given here. On the same way, we'll discuss about the metal, color, and of course the range. So we'll go for it. So here we have metal. The metal we have is lithium, sodium, potassium, rubidium, and cesium. So here we go. The characteristics that we'll discuss about on all these. The first we have is your color. Second we discuss about so for that, the color we have for lithium, crimson red. For sodium, when the range is 670.8. For sodium it is yellow, then it is 589.2. For potassium it will be violet, then 766.5, 766.5 here. And the next we have for red, violet, it is 780.0. For this it will be blue, 455.5. So here the alkali metals are therefore be detected by the respective flame test, and that can be determined by flame photometry or atomic absorptions spectroscopy. And these elements when irradiated with light, and that the light energy absorbed may be sufficient to make an atom lose electron. So for that we'll be having an atomic and physical property of the alkali metal. We'll discuss that here, and that will be the important one, so we go for it. So here we go. Atomic and physical properties of the alkali metal. The first property we discuss, that is for lithium Li, sodium Na, potassium K, rubidium Rb, cesium SCS, and francium is Fr. Okay, now we have a properties as well. So first property we have atomic number. The another property we have atomic mass. Which is in gram mole inverse. Another we have electronic configuration. First we'll discuss these three. So for atomic number for lithium is 3, for sodium it is 11, atomic number of potassium is 19, atomic number for rubidium is 37, cesium for 55, and for francium it is 87. Atomic mass a gram mole inverse, it will be 6.94, 22.99, 39.10, 85.47, 132.91, and that is 223. Okay, now talking about for the electronic configuration, which is helium 2s1, neon 3s1, argon 4s1, krypton 5s1, xenon 6s1, and Rn 7s1. These were the electronic configuration of these these properties of this alkali metal here. Now talking about the ionization enthalpy, and which is being the further discuss about it. Let's go for it. So discuss about the ionization enthalpy. That is, we have for lithium, for sodium, for potassium, for pythium, for cesium, and for francium. So for ionization enthalpy, after ionization enthalpy we have for ionization enthalpy, which is in kilojoule mole inverse. Then we have another property is hydration enthalpy. With respect kilojoule mole inverse. Then we have your metallic radius. Then we have ionic radius, metal plus by pm. Then your melting point by Kelvin, boiling point by Kelvin. Then you have another one, it is your density by gram centimeter inverse cube. Then we have your standard potentials. Which is by volt for metal plus by metal. And the another we have here is occurrence in lithosphere. Now we discuss one by one all these properties here. So for ionization enthalpy, 520. For lithium, for sodium it is 496. For potassium it is 419. For rubidium it is 403. And for cesium it is 376. And for francium it is near about 375. Hydration enthalpy for lithium we have here is near about 506. That is minus 526. Then it is 506. This is minus 406, minus 330, minus 310, and minus 276. And we don't have metallic radius. It will be 152 for lithium, 186 is for sodium, 227 for potassium, and 248 for rubidium, 265 for cesium. We have for ionic, that is your ionic radius we talk about. For it is 76, 102, 138, 152, 167 and 180. Now for melting point it will be 454, 371, 336, 312, 302. For boiling point it will be 1615, 1156, 1032, 961, 944 and for density it is 0.53, 0.97, 0.86, 1.53, 1.90 blank. For standard potentials it will be minus 3.04, minus 2.71, 4, minus 2.925, and minus 2.930, minus 2.927 blank. Occurrence in lithosphere, that is we have here is for occurrence in lithosphere is 18, 2.27, 1.84 and 78.14, 12, 2.6 and minus near about 110 to the power minus 18 here. So it will be the first start, that will be it is your, that is ppm part per million, and the second we have percentage by weight, lithosphere, so that the earth over the layer its overall and the part of the upper mantle, and this property makes the cesium and potassium useful as electrodes in photoelectric cells. So here we gonna end up with, and we'll discuss the rest in the next coming class, which is of 17th class. So other than that, we had done your quantitative aptitude. Here in that we are dealing with your arithmetical ability, and then we'll discuss another one where part 1 physics we are dealing here. Part 1 chemistry we had done for class 11, which is your unit 1, which we had done is your some basic concepts of chemistry. The unit 2 is your structures of atom. Unit 3 is classifications of elements and periodicity in the properties. Unit 4 is chemical bonding and molecular structure. Unit 5 is your states of matter. Unit 6 is thermodynamics. Unit 7 is equilibrium, and then we'll discuss Unit 8, which is your redox reaction. Unit 9 is your hydrogen. Unit 10 is your S block element. Unit 11 is your the P block element. Unit 12 is organic chemistry. That is your organic chemistry, some basic principles of technique. Unit 13 is your hydrocarbons, and Unit 14 is your environmental chemistry. So we're gonna end up with this. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.